Today is going to be about, we're going to talk about physics and collisions, live mocap, and having interactions with your performer in the environment so we can build up for this weekend's lab, and you guys can get a better idea of how you're going to do your midterm presentations and ultimately your final projects. So let's start off from scratch. How about today? I like that idea. And we're going to install the starter content so we have some things to play with, some built-in particles, explosions, and some materials. The starter content is about 600 megabytes of content, so don't always install it to every project unless you just want to waste space. I often make a side project that's, I call it like filter or asset manager, and whenever I want to test out something new package, some new marketplace thing, I always throw things into there, and then I play around with it, and then I only migrate the things I like into my ultimate project. You'll see, especially throughout the semester and as you work with other people, they get really bloated really quickly with things you're not going to use, and that can be a source of some unwanted frustration later on. We're going to make this one a blank one because we're going to be, we don't need to have a first person because we are going to be the performers today, and I am going to say it's desktop maximum quality, and let's include the starter content this time, and we'll make this week 04. That's fine. And then we're also going to get into interactivity. I'm going to show you guys blueprints. We've only briefly glossed over them. I'm going to show you do interactivity with the visual scripting language of blueprints, which is a data flow programming, but it's also C++. Everything is called C++. Everything is, all the functions are the same names as underlying code, and all the data types are the same. You are learning C++, but without having to worry about syntax errors. So it's a great way of, I find it kind of a didactic way of learning C++, but also being functional for making things as well. And we have our Ames chairs, statue, and table. I'm happy, ready to go. And let's just talk about some physics in general. I have a chair that's already here, and let's look at the data, the details over here on the right side. We've already talked about the mesh that it is. We'll get into materials next week a little bit more. And then we have some things about physics and collisions. So game engines are about, well, they do a lot of things. They have great like shadows and real-time lighting. But for today, we want to emphasize the fact that they understand collisions and they understand physics. These features are usually turned off by default because it doesn't want to have to calculate them all the time. And when I say all the time, I mean every frame. Every tick of every second. We're talking about sometimes in VR 90 times per second. You know, we don't want to have everything always interacting with everything at all times. So this ability for game engines to calculate it is there, but we've learned where to turn it on and where to turn it off. So for this chair, I can see that we have a physics tab and a collisions tab. So let's talk first about physics. Simulate physics, which just means that if I turn it on, first of all, I want to get rid of this whole lighting needs to be rebuilt. I'm going to move this light source, make it movable, so it's no longer trying to bake lights, and we can just move on and not worry about error messages. Back to the chair. If I hit play, the chair is there. That's where I place it. It's all going to do. It has a physics, it doesn't have physics enabled, but it does have the ability to turn it on. If I click this box, we then have physics, right? Simple enough. These are things that then our performer can interact with, pick up, push around, that kind of stuff. We have associated things like a mass. So when you bring in objects, and we'll talk about this more when we talk about finding assets in the real world, it's important to bring in assets to the right size, because this whole process of where it loads in, like you might have seen when it loaded in your skeletal character, it like took a while to process all the frames and all the data. It's allocating things to it like, what is its mass? So this is automatically known as, or automatically it's allocated as 119 kilograms. Who deals with kilograms in a day-to-day basis? What's a kilogram?
I don't know how to transfer around.
Like what in this room would be like? Like what is that speaker in the corner, or what? That's like 12 kilograms. So this chair is like 10 times the weight of that guitar. That makes sense. So the engine's pretty smart about allocating these weights based off of shapes and stuff like that. So you can also override it, and I can say that it's super heavy if I want it to bounce less or roll faster. All that kind of stuff. It's kind of intuitive with the way we're used to dealing with the physics of everyday life. Dampening means that it won't roll as far, it won't tumble over as far, it won't scoot as far, all that kind of stuff. And then we have things like gravity. So what happens if we turn on physics and we turn off gravity? Kind of nothing. But what if I push it? Nothing. Let's take another chair. Turn on physics on this chair, but keep gravity on. Turn on physics, but turn off gravity. This is what happens. And they're just going to float away. See? So this is stuff that's already calculated. So what's more than that is that not only does it react in the way you want for gravity, negative 9.8 meters per second squared, but it also knows when these things are touching each other. These are these collision or what are called overlap and begins and ends. And we can get information of knowing when these things hit. I mean, Unreal Engine was built in 1998 as a first-person shooter. Of course, we're going to know when somebody gets shot and then gets scores, and that's how things increment in. We know about because they had like this laser beam collide with them. I feel like we're watching Interstellar or something right now. Just keep it going. Hey, how you doing? What's going on? Oh no, bye. Hey, whoa. So, and then if I want to get back to the chairs, I'm just going to double click and it zooms me right back in so I don't get too lost. And then you'll see I keep on starting back here. This is this player start. We can kind of move this where we want to, and this, when we hit play, will be right there. There's another selection that I could say, just use my current camera location. Like turn on this and I hit play, it just happens wherever I'm at. So we can kind of navigate between those two. We want to see where these simulations happen. On top of that, you might have seen a play for Simulate. Simulate is cool because let's say you have like a whole bunch of rocks. You want them to pile up in a natural way and you don't want to place them all in like a really specific area. If I hit Simulate, let them fall. Well, that's not going to work. I gotta do it a little bit. Gotta have something usable. They can't fly away too much. All right, so let's simulate. He falls. Let's try it again. Make it fall on. I want to fall on the side, essentially. Let's go over to this table. And I'm just using the WASD keys to kind of navigate around pretty quickly. There, it's going to hit the table and clip off and fall down. Boom. All right, so I'm like, oh, that's supernatural, and we have all these like 800 things there. We want them to be like that. With these objects selected, if I hit the letter K, it says save state for my chair for rotation and position. I hit stop. That chair now starts there. That's a cool way of doing a layout as you build your scenes, is that you can like stack dominoes, let them fall, hit simulate, and then save your changes by the K button, or you can right click, and then I think that's one of these options right around here. Another option I saw real quick is if I get lost where I'm at, if I hit F, it brings me back to the focus of the thing I'm selecting. So that's some simple navigation stuff that maybe I didn't know for a year, and when I found out, I was like, oh, this is how you do that. Oh, well, that saves me so much time. So now the knowledge is yours. All right, so we know about when things are falling. That's great. I'll leave these guys over here so they're continually falling, and we can have that as a thing. But what I want to do to, I think Aaron's outside. Can you help him?
Oh. No.
So there's a thing, so we have a default for knowing when collisions happen, and that's called a trigger box, or a box trigger, trigger volume. These are kind of all the same thing. This is a thing that already knows to send out a value when you collided with it, okay? And we can collide with it just by sending our camera through it. All right? So when we get in here, when we hit this box, we want it to do something. So let's get into our first level blueprint, or our first blueprint. So the prerequisite of this class is knowing a little bit about introductory level coding. And we're going to get kind of into classes and objects pretty quickly today. But first of all, I want to show you where you should script most ideas to start off with, which is your level blueprint. These are things that only happen within this level. If we change maps, this code no longer is relevant, which is why you'd make a class, because that interaction can happen throughout every level. If you want to have a light switch always turn on a light, then that happens throughout your entire game. You make that into a Blueprint class so that you can continue to use that every level. But if we're just scripting something right here, like something with a specific one-time trigger, I want to have this collision do something, and we're going to do it in the Blueprint for the level only. All right, so there it is, and I want to be able to fly through it and have it do something. This is our first time looking at blueprints, really. It has a graph paper. You could do variables and macros and functions and stuff like that, and your details over here. And everything is kind of available for by right-clicking. And we have two ways of right-clicking. We have what's called context-sensitive. So it knows everything that is available for a trigger volume, which is a thing that's invisible, but sends out events when it is overlapped and when you end overlapping it. So everything that's available to me, every function in Unreal and C++ is right here. And we could say, oh, how does it handle audio? Well, it can activate a reverb effect. It can deactivate a reverb effect. It can play a sound at a specific location. This is a great idea just to understand the functionality of what this engine can possibly do. But what's also cool is that, and sometimes it's getting in your way because the engine doesn't understand what you want to do with it. Let's take off context sensitive. This is every single function inside the engine. This is all 6 gigabytes of whatever. This is everything that you know how to do that that is in Blueprints. So that's kind of cool that everything's kind of there for us, and we just have to say, I want to set a light color. And oh look, there is set light color. That's actually a function. This is a function that's written in C++ that we can use data to change. So I'm assuming that we're going to probably do something with a light in this trigger box. I'm going to go back to saying context sensitive, and it has a special header up at the top that is doing things only with events. Events are how we're going to execute functions and how we can call functions based off this trigger volume. So let's just get into showing you. We're talking about collisions today, and I want to do something when I go into the box. I want it to trigger something. So here we are. This is an event. Events are highlighted in red. An event could be anything like it could be a key press. Like I can right click and say spacebar. When spacebar is pressed or when spacebar is released, these are two events. These white triangles are called execution pins, and you can see that when you overlap something, I want it to execute this function. This is how the data flows. It flows. It doesn't matter if it's this way, this way, this way. It's always forcing along from the arrow out to the arrow in. All right. So when I overlap this thing, let's just turn on and off lights for right now. I'm going to hold down Alt and I can click, and that takes away execution. Let's turn a light off and on. We have a box here. Let's look for a light. Point light. There we go. And I want when I pass through here, I want to toggle the visibility. Now I have this point light selected. If I right click, I can bring in a reference to the point light now. I can also drag and drop a reference to the point light. Same thing. All right, and what I say I want to do, I want to toggle visibility. And there we have toggling visibility. All right, let's take a look and see if this works. I'm going to hit play, go in, off, on, off, right? Light goes off, light goes on, light goes off. There you go. And then if we were able to, I know this is limited real estate, kind of look over here, you would actually see it executing. This is a really cool way of visualizing where your data is going. I think Touch Designer does this as well. It's really nice for debugging, especially if you have multiple screens. So I see that this is executing. That's great. So very cool. We like the idea of trigger boxes and lights. Let's take a look at the properties. We looked at the physics properties. We don't want this to float away, but we want to look at now the collision properties. And the two important things to look at is that it generates overlap events, and that's the secret here, is that if this wasn't clicked on, let's try it, we're not going to generate overlap events. It's overlapping, but it's not sending an event. As I said, you execute events, and if we're not sending out events, then the engine's like, thank you, I'm not going to calculate that, I'm lazy. Game engines are lazy, they don't want to do any work. You have to tell them, no, you got to work for me. So let's turn them back on and make sure that you're generating events. And then there's some general presets. For instance, this one's known as a trigger, which is a special one where it doesn't take a volume, but I can easily tell it to do things like block, and then you couldn't be able to walk through it. And that's like for a wall, you want to be able to hit a wall and not walk through it, and these are how the collisions are working. You want a ball to hit a wall and bounce off it. Let's put a cube here real quick. Cube right here. This one is set to block all, and then we take a sphere, put it on top. This one also we could say is block all, or block all dynamic, moving around, and simulate physics. And they don't go through each other, right? As expected. But if I take this block and I take it and I say there's no collision, it goes right through it. Right? So we have control over all this, and we can tell it what it needs to do. It can go through this block, but it can still say no collision, but it can still generate an overlap event. So it's just the combination of just these little details right here can be extremely powerful for scripting your levels. What I want to get into, though, is the fact that what if we really love these lights going off and on, but we want to do it a bunch of times? So instead of creating a now imagine if we want to do 20 of these, right? We have 20 trigger boxes, and we have 20 lights. You can see very quickly that doing this over and over and over again is going to get silly. And so the point for us, and the reason why we study data and data cleaning, and realizing that sometimes it's better to do a good performance in the first place, is working smarter instead of working harder. So I'm going to get rid of all this stuff. And I'm going to get rid of the trigger volume this way and the light this way. And we're going to create our first blueprint from scratch. This is going to be called an actor blueprint. In Unity, if you've been using Unity for a while, it's the same thing as making a prefab. It's something that you can do over and over again and instance out. All right? We're smart people, so we like to keep things organized so that other people can see our work and help us out. So we can say assets folder. Instead of our assets folder, I'm going to make a blueprints folder. And in my blueprints folder, I'm going to create a blueprint called BP Light. Oh, this is an actor blueprint. Actor is just the most general kind. It's a thing that lives in the world. These are actors on a stage. That's all I have to know. Everything else is a more specific use case. This has everything available to it. And the style guide for Unreal is doing a blueprint is BP underscore, and then whatever you want to call it. I can give you guys a style guide for how to name for naming conventions for all of Unreal later on, so that you guys can collaborate better. If I double click this, it's very similar to our level blueprint, except that we now have a kind of a viewport of its own little world. To kind of prove that this blueprint is happening in real life, we're going to put it here as well. And all this is called a scene root. This is an invisible, like little sprite. It's a little mark just so we know how to place it. And let's place in that light again. These are all components of a blueprint. I'm going to say light, point light, and then if I move it up, compile, and look over here, there it is there too. So whatever I'm doing inside of this blueprint is also happening to the blueprint in the world. See that? And what's the other thing we want to do is we want to be able to trigger that light, and I'm going to again look for a collision, and I'm going to use a box collision. There it is sitting on top of the grid. All right, now I can move it down. I'm going to parent it back to the root and move it down so it's on the floor so I can walk through it. Cool. Enough for me. Point. Okay, great. So what happens is now our box, when I add an event for it, for overlap, it has all these other things I can drill down. I can say only when it's hit by a certain component or another actor or another thing. Like there's all these different stuff. I don't care. If anything hits it, let's execute something. Let's go back into that light color. bring in a reference to the light, and I want to set light color. So when we overlap, it's going to set the color, but the color it's going to set it to is black, right? We have an RGB and A. Everyone's familiar with all this stuff. Let's talk about RGB and A separately. These are combined. This is kind of a, it's called a structure. We're going to split the pen by right-clicking, and there we go. RGB and A. If we want to go back, this is, we can recombine it. This is basically linear. This is called a linear color, and this is if we want to drive a gradient or something like that. We want things to happen over time. But for right now, we want a single ping of overlapping, and I want it to be able to expose the RGB and the A. And these are normalized values from 0 to 1. We'll say random float between in a range between 0 and 1. So as you can guess, every time we ping this, we're going to send a new unique value between 0 and 1 to RGB and A, and we'll leave alpha at 1 so that you can see it very well. All right? Everything I've done now has been propagated to this right here. So as we fly into this, I'm going to make it a little bit bigger actually. We have the details panel over here. I can scale it. Let's make it a little wider. Let's say just not too much bigger. There we go. Compile again. There we go. It's easier to get into. And when I hit play, cool. All right. So this is a class. This is an actor class of Blueprint, and from our exposure to coding so far, we know that if you have a class, every instance of it is an object of a class. And what's expected behavior is that, what's the expected behavior of this, guys? Like, is everyone going to be the same color, or are they going to be different colors? So it's expected that they're all actually getting a unique random. And they're all getting their own unique color. Cool. Great. So now we get the idea of collisions and lights, making pretty lights. This is obviously an awesome disco floor for our character to dance on and everything. But I want to do just a couple of more things. I want to show also like moving things up and down and stuff, just because it might be useful for you to make like little platforms for people to jump up on and stuff like that. Another panel, the details panel thing I want you guys to look at is the fact that these have to be set as movable. Again, this table is lazy, the engine's lazy, it wants it to say it never moves. But we want this to be able to be movable. We've now allocated a little bit more resources to be polling for when this thing moves. It can be moved by physics, or we can bring in a reference to back to our level blueprint. And then those of you who are familiar with keyframe animation can get to something like a thing called a timeline. Let's just, in nowhere, let's see, timeline. There you go. Timeline is always the very last thing. And a timeline is just we have floats and vectors, and as I said before, we have a color track. And these are just ways of adding keyframes. Things can go up and down, left and right. All right, so I'm going to make a keyframe by right-clicking and saying at 0, be 0, and it's 5 seconds long. So at 5, be, I don't know, 500. Autoplay and loop back and forth. Cool. And then we had a variable for that track. It's called new track 0. We can call this up, down, whatever, doesn't matter. So we're gonna make something go up and down. There it is. And we're gonna update what we do. We can set world location. So again, we just kind of guess what we're doing. Like I want to set the world. We're doing things we're setting and we're getting values. And keep these things organized if we want. And what I want to do, I'm going to split this up. This is a vector. This is an x, y, and z. And we're going to send it just up on the z-axis. And this is to show you that this stuff is existing. You guys can get a little bit more of a deep dive to get into it later on. But now I have something that's going up 500 centimeters, which is an Unreal unit, and then it's kind of starting again from scratch. Just looping. No, it doesn't play through. It doesn't have a what is it called? Playhead. But the important things to kind of reiterate is the fact that I have set it to autoplay. Otherwise, we'd have to trigger that. Right? Let me turn off autoplay. And then we can set it to a collision to be it. Or I can set it to, it needs to start, right? Let's go back to spacebar. This is also an event. It's a key press. So we're going to start it playing, but it's already set the loop, and it gives me a little icon here for looping. So if I hit play, it's there doing whatever. I don't even know where it is. Probably at 0. Oh, it's where it normally is. And we're going to hit space, and it's going to pull it over to 0, 0, 0. And then you go up and down. Right. So that could be you step on a trigger box, and a platform starts taking it down. Doors open, lights turn on. This is the kind of power you have in scripting and blueprints, that things can kind of happen pretty quickly. My favorite one to get into is we'll just kind of jump ahead into a thing called slow-mo. This is time dilation. So, oops, I meant to set, not get. Set global time dilation. So instead of making that table up and down, I am going to, when I hit spacebar, set it to go into, 1 would be normal time, going to slow motion. All right. Let's take a look at these chairs that are about to fall, and now we have slow motion. So you get slow motion. The thing is, I'm actually pressing forward right now too. See how slow I'm going? I'm also going in slow motion. I'm also being restricted by, this is the whole world. It's like substepping physics. The definition of time has changed, right? And we're about to get into live motion capture. I'm going to show you that, and I'm pushing it right there actually. Twink. What we're getting into in live motion capture is that we can't actually, the data is in real time, the performer's in real time. So we're going to see that the world can slow down around a performer, but the performer can continue to do things in real time and push things away. It's going to be a little fun. So we're about to jump into that real quick. All right. So time dilation, super fun and powerful. I want to really quickly jump back up here and take a look at these 3 default events that happen. It's important for you guys to know, especially coming from things like processing, JavaScript, Arduino. There's some parallels to that. This event begin play, that's the same thing as like your void setup. This same thing that happens immediately. This is the stuff where you kind of like, I need to set these variables, I need to do this. All the stuff needs to happen immediately, and you can have this huge long event begin plays of all the things you need to do. You also have a thing called a construction script, and this is like an event pre-begin play. Just like I showed you that if I put this actor blueprint inside this world, the things that are happening in the blueprint happen in the real world. If you want to actually see things space out and see things move around, you want to put that in the construction script. That is the world that you can build worlds inside this construction script, and that's before begin play. And then things can happen on begin play, and then as you're used to with your what's it called, your event, your draw frame. If we go back to the graph, this event tick is what happens on every single ping of the frame as it goes through. So these are things that you want to pull for constantly, like if you want to get position of something and all that kind of stuff and send it around. So these are the kind of the parallels between those worlds that you've already come from. It's right here and ready for you to kind of hook up to your nodes. So let's start working on the. Or any questions about this stuff so far? I know that's a overview of a lot of things you guys can play around with and have a lot of fun with. But is there anything completely like not clear, or you wanted to see if like it can be broken even further? Is always going to break things. Yeah, go for everything.
The blueprint is for the hosting of certain level.
So the level blueprint where I'm doing the time dilation is only in this level. As soon as I go to the next level, spacebar won't do anything unless I put that script in there again. But this class blueprint, this actor blueprint that's of this trigger box and this light, I can bring that into any level because it's in my engine, and it's something that I can, or it's in my content browser, and it's something that I can actually I can like right-click, find out where it lives inside of my Explorer, and then I can take this U asset file and I can email it to you. You can put it into your thing, and then you're off and running. So it all works. What's also cool about blueprints, while we're talking about it, is that this is also you can copy and paste it. This can be copied and pasted to another level should you need to, but also be copied and pasted into emails and that kind of stuff. It's human readable. So if you need to share your code for your little blueprint back and forth for your friends, don't send them like a 6 GB project. Just copy and paste, and it automatically converts it to this format. So that's super helpful for working in collaboration. And we'll go with some yeah. So so I have this here, and this is my level blueprint. So let's go to another level. Well, the thing is that it's not going to have a reference to this point light. This point light is something that's specific in the world, and that's about level blueprints. So certain things you'll have to find it. It'll say unknown because it doesn't know the reference to that point light. So there is some flaws with copy and paste in this way. But if like you have a really cool like this exists always, and because those are just functions that are built into the engine, I can copy and paste this, put it into Slack, and now you guys have it. I'll make it week 4. And then we have the purpose is physics and collisions and live mocap and charades and there you go. And then we're welcomed with, you gonna do it? Is it too much? Computer says no. All right. I'm sure there's Pastebin or something like that. Let's figure it out together. Right, and then I can send this thing or something. Anyway, we can figure out a way of hosting this stuff. Do paste. We haven't installed any. Add-ons. As soon as you guys install add-ons, anyone's welcome to. There you go. Now you guys can grab that. All right, so let's move on so we can make sure we get time to do everything today. I'm going to bring in an actor, and we're going to talk about another kind of blueprint real quick. So assets, skeletal meshes, and let's import my generic female base mesh as is, and this is just a I've been using this. This was like the first thing on Mixamo, and it's no longer there. And I've been using this for like 3 years, so it's just, if you want it, I'll send it to you. It's no longer a thing. So what we're going to do is we want to actually now talk about doing live motion capture data. We want to take this stuff from Motive and send it to this character. We don't really care about the mesh. What we care about is the skeleton underneath. And we're all going to become very, very familiar with the hierarchy of skeletal bones inside of all 3D content creation packages, and then Unreal specifically. And we want to learn how we can either drive directly with what's called forward kinematics, the bones that should correlate 1-to-1, and then interpolate between other bones that don't exist from the data so that it has a naturalistic movement. We're going to be using a plugin today called iKinema, and iKinema is an expensive plugin that we're going to use on this laptop right now for this weekend. as we sort out the licensing issue with the bigger computer. I have it installed already. If you want to look at iKinema, it is right here. And a bunch of projects we've done at NYU have been in here. And it's a way of doing that thing we're talking about. It figures out your legs so that you can your characters can go up and down hills. That's a way of using their controllers to drive a upper body 3-point tracking in VR. Next week we'll be using Vive Puck to drive a full person doing 6-point tracking. So iKinema does a lot of these things, and we're going to kind of explore the whole suite so you guys get exposure to the expensive and the inexpensive, and you guys can really pick and choose what you want for your final project. So the so we're going to it's already installed, and I'm going to turn it on real quick. I might already even have it installed. I already have it plugged in. So iKinema, once it's installed, is right here. It's not enabled yet because I started a brand new project from scratch. First of all, I'm going to save all. And you guys, this is what you're going to be all doing in the lab. You can prepare a level first, and then when you bring it in, we'll transfer it over to this computer, and we'll be installing the plugin. And then we'll be running at it. So I'm going to enable, and it's going to ask me to restart now. That's why I saved everything. And Spencer, level blueprints, it's just a quicker way of doing things. And oftentimes when you start talking about blueprint communication, where you have to cast and do interfaces and all this other communication, it gets really, really complicated too quickly. And you end up having to pull with a lot of event ticks, which slows down your computation, especially with VR. So oftentimes it's easier to do simple interactions in level blueprint. And often most VR pieces I see, beyond like grabbing, and interactions that are things with controllers, are almost all level blueprints, because there's just things that happen once because you're only on one level, and it's just as simple, this happens at this point, and it's all running off of a timeline. We'll get into a timeline after the midterms, but basically there's a thing called a level sequencer, which is like a playhead for describing like a non-linear editor, and that's only inside the level blueprints, and that's how you're going to be triggering a lot of things happening, and then to be casting to other blueprints to start sending out other functions. We can talk about more later on though. So anyway, now iKinema is enabled, it's ready to go. And as I said before, we're going to talk about the skeleton right here. So now when I right click, I have this button for iKinema rig actions, and I'm going to create an iKinema rig. All right. I am connected to the mocap computer, actually. So let me actually jump into that first. So we have a mocap user. So this is the mocap computer over there, and it looks like it was restarted. That's fine. I'm going to turn on Motive, and we're going to all the instructions are included in the links I gave you, but we'll go over it right now so you have it on screen recording. We're going to open existing project, and I guess we're going to watch Jing's star shine one more time. No, where's I know I'm in a different user. I guess we're just going to use whatever was used last. This is the dangers of having a public computer. Who do we have? Lillian.
Oh, this from class?
This is the last thing that was reported on this computer, so it's probably from class. Is that too much? Is that picking on you too much?
No.
Okay. All right, so back to capture layout. So it's live, and let's go into edit. What's important to note is that that's when we took off the things. There we go. We got the Superman. Maybe Superman might be the most fun to do. I don't know. I mean, Superman might be. I don't know if it's the best educational resource. I think this one is. All right. So let's just say right now this could be live. It could be canned. What we can do is if we have live, what's cool with that is that we can be recording local data and also streaming. So if we're doing a performance, we can have our own locally stored stuff. It's a great performance. We can clean that up and have the perfect take for later on, but we're also performing at the same time. We've already recorded ours, so we're going to be sending out data. We'll be sending out live data of a pre-recorded setup. Here at the top, there's a thing called a streaming pane. It's also under View, under Data Streaming. And on the right side here are the options for sending out data. You can see down here, it's actually always been on, and that's probably why Motive has been crashing, is because we've been sending out 120 frames per second of data constantly of everything we've been doing. So I'm going to go through some of these settings. This is the IP of this computer. We're going to be broadcasting it from here, or multicasting it from here. And we want to send out rigid bodies for doing props, skeletons, which what this is right here, and local rigid bodies. And everything else is by default set up correctly. This is checked. This is all ready to go. I'm just going to have this looping here, and that's ready to go. Fantastic. And now we're going to come into this iKinema rig. Here's our female base mesh, and you see this is her purple skeleton right there that's driving her. And you see this is all information we're going to put in from the other computer. I've done this many times, so I have it all memorized. We are OptiTrack NatNet is our streaming protocol. And this is, again, on all the videos you'll be seeing as well. It's 192.168.1.2. The port is 1511. And the subject name is Lillian. Going back to the naming conventions, don't use spaces, and make sure that you realize that this is case sensitive. Cat, is it Lillian with lowercase?
Are you asking me?
Yeah.
I don't have my glasses on.
Oh, no, but the computer behind you?
Oh.
I can log in again.
Uppercase.
Is that right, Lillian? All right. The import scale will default its settings. 1 is fine. We want it to be 1:1. Yes, the Y is facing up. That was something we saw on OptiTrack. And then this 0 source rotation means it's going to make it force the data into a T-pose. And now I'm going to import the actor. And there is Lillian's proportions. All right, so she happens to have the same kind of leg size as our base mesh, but she seems to have a taller torso. That's fine. The process we're doing is called retargeting, and we're moving. We're having one skeleton drive another skeleton, and that's kind of the whole point. I'm just going to line them up a little bit better on the hips. So you can kind of see better. Or I won't if it's going to be causing. Oh, there we go. So there we go. So the hips are right on the. There we go. So you can see they're really aligned, especially in the feet. But then it kind of gets into a different proportion here. So our goal is to use iKinema to do real-time solving. I'm not seeing any fingers here. I don't want to deal with the fingers. We're not deleting the fingers from the skeleton. We're just deleting it from this plugin, so we're not having to deal with all this junk. I'm just deleting it from the interface, so I don't have to deal with looking at it. The fingers are still part of the skeleton should I want to pose them and put something in their hands and stuff. All right? And now we're dealing with more of a simplified skeleton here that's just the essential things. And the goal is to have certain parts of the body be bound together and either drive position or rotation, or position and rotation. And iKinema has already done a lot of that hard work for us, and it calls these things tasks. You're going to have things like chest tasks, hip tasks, head tasks, hand tasks, and feet tasks. It's going to bind these skeletons together, and all the things in between, it's going to solve for in a realistic manner so that it gives a little bit of play, so you can have things in different proportions, driving things in different proportions, but things like hands always have the right orientation, or head, we can turn our head in the right way, even though the head might be a different shape. It's definitely something to play around with and deal with, like, be Jack Skellington, like a really super tall and thin character, or be a much more squat character. You can see they can all be driven in real time. So the goal is now to right-click on here, and actually, no, I have to map these things. You might think this is tedious. This is only the first time we could say this is a template. What we are doing here is literally saying we have a bunch of different ways of naming these bones, and I need to tell it which way. Like hips here in the iKinema rig is actually going to be Lillian hips here. Spine is abs. We don't have a 3-bone spine. We have a 2-bone spine. So do chest, and iKinema will solve for this other one. Neck is neck. And what's good about this process is, although it's tedious, you definitely learn what all the bones are in your body. Shoulder bones connected to the upper left arm bone, and the upper left arm bone is connected to the forearm bone, and the hand bone. And it goes through pretty quickly. And what's good about this is the bottom left. We're going to save this template. And then if you see over here, I can load a template. So every time I bring in a Mixamo skeleton, I can just do this and I'll never do this again. But it's good to start off with the first time. Right shoulder, right forearm, right hand. And then we'll finish up the legs. Shin, foot, and toe. And because we were only doing 37-point tracking, we don't have a toe end, which you guys know means you have ball foots. So you can bend your feet in two sections. Then right, 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 and right. Great. So now they're saved. I can make a template knowing that this is a Mixamo skeleton or whatever it is. Save the template so I can load it again and close out of here. And then I want to bind a couple of things. I'm going to create a task or constraint for hips, chest, head, hands, so that we can move our hands around. They're tied together. And we want the feet to move together as well. This is all in the videos that I've put on the syllabus as well. And they go into much greater detail. Foot, and then we'll save. Great. So we're almost ready to go see this live data in action. What we want to do now is we've talked about blueprints, which drive interactions in our world. We're going to talk about a animation blueprint, which drives our animations. And we're doing one thing. We're going to create an animation blueprint. And this one's called Female Mesh. And when we open this up, you'll see that we want basically to say, give me data and make it my final thing. And quite literally, it's just take this mocap data and all that stuff we just put in. There again, we're going to say, give me my data. 192.168.1.2, 1511. It's called Lillian. And then we want to reconnect in case it falls apart. And in between that, we want to grab this Ikinema file so we can know all the data we put in there. Retarget. Save. Oh, I always forget this, and you will too. Over on the right, we could choose OptiTrack. Boink. Click in here, and look at there. There's Lillian. In real time. Pre-recorded, but in real time, playing back. So we've proven that by looking in here, that we have real-time data. And what's cool about that is that we can then go back to what we know at Blueprint class, an actor, BP, Lillian. With it, the skeletal mesh selected, I can bring in, oops, is it not selected? It's selected. I can then context sensitive bring in the mesh, rotate it so it's facing front. That's not front. As I said, rotate it so it's facing front. And then on the right side it says animation blueprint. Yes, we will. This one. Dun, 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 dun. There we go. And there we go, there's a little birdie. And what's good about having this is that then we can start adding in these particles, right? We can have all these different particle systems that are attached to certain bones, right? I want this to be on the head. Which one do I want it to be? Oh, I don't know. Surprise me. Make it fire. Right, attached to the whole body apparently. Let's scale that down a little bit. Right. It's a bird on fire right there. Is that a movie? Boom, boom, boom. Another particle system. We're going to put it on the skeleton itself. And I'm just choosing different bones I want to attach it to. Let's put it on our left hand. And this can be, I don't know, smoke. Smoke's out there. Let's Probably shouldn't have it playing in real time. There we go. Everything's fine. Save. And just as before, because we have a class, we then can have many actors of a class. And the whole world's falling around her. Great, but she's not making my lights go. So let's take a look at her settings real quick. Back in here, we just forgot that it wasn't actually generating any overlap events. So let's do that. And then if we were supposed to, if we want to put a bunch of spheres in there, let's go ahead and make her also block everything so that she can hit things with her own hand. And so you can actually like play a game of baseball or something like that and rely on physics simulations. Yeah, it's real-time data is going on. I could hit pause over there. I could turn off the animation blueprint here. Also not be on a laptop. All these things are valid. All right, and also save more often. Save early, save often. So now the lights should all be working. I'm just gonna give it also. Do we still have our level blueprint? So what I'm gonna do is I'm gonna copy this. And what we're going to say is that when I hit the space bar, it's going to be normal time, but otherwise it'll always be slow time. And then event begin play, at the very beginning, also be slow. So it's going to be slow by default, and when I hit the space bar, it's going to speed up, and when I let go of the space bar, it's going to go back to slow. And sphere, I'm going to hold down Alt, and I can drag off and make duplicates. All 4, duplicate again, and with all of them selected, make sure that they all have physics enabled. And then we hit play, and they're all in slow motion, falling, falling. There we go. Fast fall, fast fall. Let's turn off gravity real quick on all these guys and bring them all down. Hit play. There we go. So there's live data, and that's part of our lab this week. So we're going to hit or that is our lab this week. And so let's come back at 8:15, and we'll have somebody in the suit. We're going to do this live. And start playing a game of charades. All right? Cool.